All right, in the previous video, we talked about how to find the area of each of these shapes. We got 25 pi for one and 12.5 pi for the other. Now we're going to go ahead and find the arc length for each of them. So let's scroll down a little bit here. I will remind you that, well, we've got r equals 10 sine theta. We figured out in the last video that theta for this one went from 0 to pi. And I'll write the other one in a moment when we're doing that one. But I'll remind you that the arc length formula, which I'm going to write as AL period, there's other letters that are often used, but I like to stick with this for now. A dot L is the integral from theta 1 to theta 2 of the square root of r of theta squared plus dr over d theta squared, all with respect to theta. So r of theta is going to be this 10 sine theta. The theta 1 and the theta 2 are going to be the 0 to pi. So I'll write r equals 10 sine theta, comma, dr over d theta is just the derivative of this thing right here. That's an easy derivative. It's just 10 cosine theta. You should know that one. So I need to plug those guys in. So my arc length is integral from 0 to pi of the square root of 10 sine theta squared plus 10 cosine theta squared d theta. Now, you could Math 9 this, but I'm going to show how to do it without Math 9 because this is one that could show up with on a part of a test where we can't use our calculator to figure out that integration. So what do we do from here? Well, you need to make sure you square the 10 and the sine. That's kind of probably the biggest error with this one. Integral 0 to pi of the square root of, I wound up getting 100 sine squared theta plus, same thing with this. I need to square both the 10 and the cosine. That gives me 100 cosine squared theta d theta. Now, this should jump out to you. You should know how to, you should recognize this. Should be familiar. Integral 0 to pi of square root. What I can do is make this look better before I actually go and try to do the integral. I can simplify it down quite a bit. I'm going to factor the 100 out. That leaves me with sine squared theta plus cosine squared theta. And then d theta. What I want you to see, anytime we have sine squared plus cosine squared, if they have the same input, that's always 1. So this gives me integral from 0 to pi of the square root of just 100 times 1. I guess I don't need my square root sign to be that big. You just go like this. Which is, what's the square root of 100? Integral from 0 to pi of 10 d theta, which is 10 theta evaluated from 0 to pi, which is going to be 10 times pi minus 10 times 0, which gives me 10 times pi. And now, that's the answer. I want to really quickly comment on why this makes sense. We made the comment earlier that this was a circle of radius 5 up top, that this guy right here was a circle of radius 5. And we said, oh, well, the 25 pi area that we got matches pi r squared. What's the formula for circumference? Circumference is 2 pi r. What's the radius here? It's 5. Notice if I plug in 5 to this formula, I get that as well. So this reinforces that thing that we already know. Now, again, just like the other one, I don't always have a formula for these. So we're going to go ahead and figure out the arc length of this one right here using this integration formula. And we wouldn't have that type of formula from geometry to find the area of one of these rose curves like that right there. So we're going to find, the arc length. I'm going to find the full perimeter of that rose curve right there. So let's go back to here. All right. What was that equation? It was r equals 5 cosine of 2 theta. And remember, we did some work to figure out that theta went from 0 out to 2 pi. So I'm going to use the same formula that I did here, right there. I need to figure out r and dr d theta, just like I did with the earlier one. So again, we're finding the arc length of this thing right here, question number 2. So r equals 5 cosine of 2 theta. That is going to be this piece right here. And now I need to find dr over d theta. Sneaky little chain, nothing too crazy. I multiply by a 2. That gives me a 10. And then the derivative of cosine is negative, so I'm going to put it out front. And then I'm going to write sine of 2 theta like that. So that's dr d theta. So my arc length is equal to integral from 0. I go out to 2 pi because we figured that out earlier, of the square root squared plus squared d theta. And now fill all this in. So in the first one goes r. So I get 5 cosine of 2 theta. And then plus in this one I get my 10. I guess the negative goes there. Sine of, 2 theta. I was getting ahead of myself. So what I want you to see is this is integral 0 to 2 pi of the square root of, all right, I get 25 cosine squared 2 theta plus 100 sine squared of 2 theta, all d theta. What I want you to see here is that this one, I had 100 and 100, so I could do this sine squared and cosine squared trick. This one, I don't quite have that. I could do some of it, and there are some techniques that I could figure out to do this integration, but for purposes here, we're just going to Math 9 this. So let's go over to our Math 9. Click that, and I'm going to quit, and I'm going to go Math 9, 0, 2 pi, and then square root. And, you know, I could alpha trace it a little bit, but I'm just going to go ahead and type it in. I'm going to open parentheses, and I'm going to show you a little trick here. So, first comment, this negative got squared out. That's why that's positive there. Sometimes people want to leave this as plus. But I'm just going to type 5 cosine 2 theta and square that instead of doing the 25 and the cosine separately. So I'm just going to type essentially this right here, line, except for I'm not going to type that negative because it's going to get squared out. So I'm going to type 5 cosine theta, close again. So this close is closing that one, and I need to square it, and then I need to add, and I need to open, and I'm going to type 10, and then sine. Oh, I forgot something over here. I need a 2 theta, so I'm going to go second insert, put a 2 there. Now I'm going to come back over here, and I'm going to type my 2 theta, close, squared, and then all of that d theta. Hopefully I typed that right. And I get 48.442. Now I always want to check and see if it divides by pi easily. Divided by pi. And this one, it doesn't. So I'm just going to roll with the 48.442. So I'm going to come back here and write equals 48.442. Put a big box. Hopefully all of these processes, finding arc length in polar, and finding area in polar in green, and arc length in polar in purple, all make sense. Thanks. See you later. Bye.